Hi guys. Okay, this is the Access database where we've imported test number 21. It's just an application that I wrote so that we can view 100,000 points of data and pan through that data and get a visual representation of it and get the totals. It's pretty easy. We just pick the CSV table that we've imported. We view the results, and it tells me the average, the maximum, and the minimums for that particular sheet. It also gives me the ability that if I wanted to know where this is, I click on it and it tells me what row it is. So that's what I'm going to do. I'm going to take that number and I'm going to copy that, and I'm going to go look at the graph. At least I'm going to try to look at the graph. Waiting for it to load. It has to process the queries over the tables and whatnot. And then what I'm going to do is I'm going to put that number in here as the center marker and update my graph. So there's our peak. Our maximum is 300, right? And what's interesting that we're seeing now in this extra fine data is that there's some big power transitions occurring that we didn't have in our data before. Now we don't see it in the overview, because the overview is only a sample every 100 rows. Well, you know, we can't display more than 1,000 points on the screen at any time anyway, because the screen resolution won't let you see more than that. At any rate, if I wanted to look for that, you know, I'm expecting it would be about right here, but I see that this peak isn't all the way up, and it's because my sample is really on the edge of the slope. So I'm only getting the sample data on the edge of the slope. I'm not getting the peak. So if I want to see that peak, I have to offset my sample on that boundary, which in this case the last two digits are 98, so that's my boundary. We'll update the graph and take a look at that again. And now we see that the auto range has shifted, and now I'm getting all the way up to 300. See? So what I want to look at with a little more clarity is what's going on right here. And the way we do that is we close our window. We take our starting row and our ending row and we bring those closer together, and then that closes the window up and it gives me a more definition in there. So we'll plug in some numbers here to close that window down. And then we'll update that. And now I can see what was going on in that little section there. See, we've got this transition occurring. Now I look at that and it doesn't look so, you know, so fantastic, but if we really look at that carefully, we realize we're dealing with watts here. And we're going from a wattage here, it looks like it's maybe around 50 watts negative, all the way up here, which is over 100 watts positive. Now, in order to see what that really is, what I need to do is activate this graph, and then I can hover there and I can see that that's 113 watts up there and minus 64 watts down there. So that's a 177 watt spread, or a net value, if you take your negatives and positives together, of 49 watts of power that is missing if we would have done this with 10,000 samples per screenshot. Now I'm going to change the plot type so we can actually see the data points, and we can see here that this is actually making that transition from here to here between two data points. And now those two data points is 400 microseconds divided by 100,000 points. So we're looking at about a 4 nanosecond transition. So in 4 nanoseconds, we're making a transition from negative 64 watts to positive 113 watts. Now the interesting thing is, this is not the largest transition in this particular test. The actual largest transition occurred in number 12 CSV with 324. We'll take a look at that one. Takes a little bit longer when we're recording the movie. Okay, we'll stick that in here. And see what we've got. See, that's got a much farther transition on it. Let's zoom in on that a little closer here. So there we have it. We're going from about a negative 100 to a positive over 200 watts. It's about a 300 watt swing. And just to find out for sure, we'll go ahead and look at our points. Yeah, negative 106 on the bottom and a positive 224 on the top. So that's a pretty big swing in a 4 nanosecond space of time, and we missed that with our other samples. The reason we missed that is because our other samples at 10,000 samples per screenshot, there's a 40 nanosecond space in between each sample. And what we're proving right here is that there's a lot of stuff happening within that space. And it makes me wonder now, if we've got these kinds of transitions occurring, and we're getting these points, I don't know, maybe that went way higher. Maybe it didn't. Maybe it just went a little bit higher. We don't know, because we don't have smooth data on this. And it's it brings a question as to how much power is really being taken from the battery, how much power is really being put back in the battery. We really don't have a good handle on it when we have these types of transitions occurring with such major swings in power in the circuit. So it would be my recommendation, if I was doing this for an agency that had hired me to do this analysis, I would tell them that they need a much faster data acquisition system that's able to make sure that we're getting linear data off of this. And what we really need, which is evident from 17 through 20, is we need to be able to data log that for several hours, maybe even a few days of continuous data. Now we're talking about terabytes of data storage. Well, I think you guys get the idea, and I'm running out of time on this video, so I'm going to leave you with that. I'm not going to go into any particulars on how to use this program. Apart from there is a way to expand and close up the window here if I want to change what I'm viewing on the zoom, but there's a few little controls there. Anyways, there it is, and we'll let you guys have at it.